Hello class. Today we'll be discussing IMAP and DNS. This is Christian Allanson, and this is for class ISA 4220. Alright, first we'll be talking about the Ubuntu 16.04.1 Dovecot IMAP summary. IMAP stands for Internet Message Access Protocol. It's a protocol used by email programs such as Outlook, Thunderbird, and other services. The biggest difference between IMAP and the older POP3 is that with IMAP, your email is always left on the email service provider's server. It doesn't get deleted. If your email provider has a limit on how much email can be kept, and you receive a lot of email, then IMAP is probably not the best case for you or your server. What IMAP does, it creates a master copy of your email, which is stored on the email server, and the software used to look at it is just a window. It's just a way of looking at the master repository of all those emails. When IMAP downloads your email, it's copying the email to your computer. The original email remains on the email server's master repository. It just simply copies it onto your computer for easy access through whatever email service you decide to use. Each program using IMAP to access your email is keeping itself in sync with the master copy. So let's say if something happens to the master copy, like an email is deleted or you read the email, the change will be reflected in all email programs, allowing for access on multiple devices like an iPad or a phone or some sort of tablet on your PC. It's called cross-device synchronization. IMAP supports using folders and uploading emails. This means that if you create a folder on one machine connected to your email account using IMAP, then the folder becomes visible in all email programs connected to the email account via IMAP. It's very useful when you need to switch email providers. And another benefit of IMAP is that it doesn't always need to be connected to the internet. It's more or less constantly checking for updates and syncing the needs between your PC and the master email repository. It works if, like I said, if you don't have to be connected to the internet after it's downloaded to view it. Alright, next we'll be looking at hardening recommendations for IMAP on the Dovecot server, or the Ubuntu server. Most of the email access is usually seen through the email provider's web interface. But if you have a machine running an email client like Thunderbird, it will download the emails as they appear. And for implementing limitations for these settings is a good way to harden the IMAP server. Limiting the IMAP max line length. Sometimes clients can generate very long command lines with huge mailboxes, so you might need to raise the limit if that happens. If you are getting errors for IMAP command line too large. you might need to up the length. And next you want to limit the amount of user connections from each IP address to about 10 or as many as necessary. Next is the mail plugins. You can download any plugins, support for these plugins, whatever plugins you decide to use when installing the server. Next is how long IMAP will wait to notify a client when they're idle. And with this, it's 120 seconds. Next, you want to create a log, track what users are doing on the email server, just to make sure there's nothing suspicious going on. Next, you want to implement the it's called the start TLS, or opportunistic TLS. It's referring to extensions and plain text communication protocols. It upgrades them to an encrypted TLS or SSL connection instead of using a separate port for an encrypted connection. It's usually a countermeasure to passive monitoring. The IMAP port is 143, and it changes to the IMAP S port, which is 993. Next, we'll talk about the DNS summary. Domain name system, DNS. It's an integral part of how systems connect with each other to communicate on the internet. Without DNS, computers and the people who use the computers would be required to know specific IP addresses for whatever website they decide to visit. And with the DNS, it translates those IP addresses into, or vice versa, from the domain name, such as Google, as an example. Some applications, including most web browsers, maintain an internal cache of recent queries. This is the first place that the application will check if it has this capability in order to find the IP address of the domain in question. If it does not find the answer to its question here, it then asks the system resolver to find out what the address of the domain name is. System resolver is a component that acts as a client-side participant in a DNS query. The system resolver is a library that your operating system uses to seek out the answer for the DNS queries. System resolvers are usually what we consider stub resolvers. They're not capable of much complexity beyond searching a few static files on the system. A recursive DNS server is when a query goes from the client application to the system resolver, which is then passed to a DNS server that it has the address for. It's a DNS server that's configured to query other DNS servers until it finds the answer to the question, or the IP address in question. It will either return the answer as an error. It will either return the answer or an error message to the client if it is unable to find it. Root name server, it knows all the addresses at the top level domain, which is all the .com, .gov, .org. It's the very top of the hierarchy for querying. Next, we'll be talking about the Windows server, DNS for IIS. Um, when using the Windows server, you can use the DNS security extensions. These add security functions to the DNS protocol that can be used to prevent certain attacks, such as cache poisoning, amplification, reflection, as well as resource utilization attacks, which will be explained in a second. There are a few guides you can look on the internet, RFC 4033 to 4035. They explain how to set up or harden the DNS server. I'll explain a DNS cache poisoning attack. That is when an attacker sends falsified and usually spoofed RR information to a DNS resolver, and once it receives the false information, it stores the cache for a lifetime. And to exploit this flaw in the DNS resolver implementation, it will store the falsified information. An attacker must be able to correctly predict the DNS transaction identifier and the UDP source for the DNS query message. This is used to redirect users from legitimate sites to malicious sites, or to inform the DNS resolver to use a malicious name server. An amplification and reflection attack is when the attacks use DNS open resolvers to increase the volume of attacks and to hide the true source of an attack. Actually, they typically result in a DOS or DDoS attack. They're possible because the open resolver will respond to queries from anyone asking a question. Attackers use these DNS open resolvers for malicious activities by sending DNS messages to the open resolvers using a fake IP address. When the resolvers receive the spoofed DNS query messages, they respond by sending response messages to the target address. These types of attacks use multiple DNS resolvers, so the effects on the target devices are amplified. A resource utilization attack is when the DNS open resolvers consume all the resources on the device, such as CPU memory and socket buffers. They try to consume all available resources to negatively impact operations of the open resolver. This usually requires the device to be rebooted or the service to be stopped and restarted. You want to configure the DNS server to use static IP addresses instead of dynamic. You want to disable recursion to reduce chances of an amplification attack. How you do that is you open up the DNS manager, right-click the server name and select Properties, click the Advanced tab, and check Disable Recursion and apply it. Next, primary DNS server. The primary DNS server for Windows is called Alpha. Another thing on DNS amplification attacks is this is usually a process where the open relay is used to send fake data to another server, aiding the hacker's process to take it offline. That's their main goal. It's usually used to stop connections indefinitely. Okay. Next, the Ubuntu DNS best practices and hardening recommendations. Primary DNS software for Linux is called Bind 9. This is, I think, the third or fourth installation of Bind. It initially installs as a cache server. You can change that to other types of DNS servers if you wish. And with a cache server, you can add all the trusted IPs you want to that list. But with Bind, you should be running with a non-root account. I've written all the code out here. There are a few others to harden the DNS server. It's pretty similar to the POP3 in the previous presentation. You want to change permissions and ownership on these specific destinations, and using the visual editor that is installed on Linux servers. You want to edit the file etc bind named conf options, and under the options you want to restrict the DNS server to listen to only specific interfaces, certain ports like port 53, and you want to restrict which host can perform zone transfers, and restricting recursive queries to trusted clients. You don't want anyone who's untrusted to be able to listen on to the DNS server in question. And that is all.